Hello, this is my homemade power bank. It's got 20 of these 18650 cells all put together using this Vruzend system of end caps and linking strips. This might look big, but actually it doesn't have a huge amount of energy storage because these cells are Samsung 13Q cells, which means they're 1300 milliamp hours, which is less than half, I think, of the maximum energy density cells you can get these days. Now, as you can see, I've put this voltmeter on here. It's a 2-wire voltmeter. It's not on all the time because it drains current from the cells. Let's clip it on. And yes, I was charging this yesterday through this. This is one of these boards that's sort of come out of or intended to go into a power bank. It's quite a good one. It's got USB-C, both input and output, USB micro B for input, a USB-A output, but that's also quick charge, is it compatible, so that can give higher voltages than 5 volts. Little button there and a set of lights. All 4 lights, because yes, it's quite fully charged. So today what I thought I'd do is actually make this bigger. It's heavy enough as it is already, but yeah, the capacity of this is not wonderful. So if I compare it just for a moment with this RAV power bank, it's a lot taller, my homemade one, and it's wider, and it might even be longer. It's about the same. Now this is a 20,000 milliamp hour power bank. I think it's written on there somewhere in minuscule writing. And this is a 26,000 milliamp hour power bank, so it's not that much bigger. And because there are 20 cells, you can multiply 20 by 1300 milliamp hours. Sorry, 26,000 milliamp hours. Yeah, 26 amp hours. Now the cells that are in here, these Samsung INR 18650 13Q cells, came out of these. I scored a whole load of these batteries for Wix Power Tools some time ago for £1 each, I think they were. So we'll open some new ones of these up. I'll make 2 new modules. Now when I say modules, I'm talking about 4 cells in a square block. So I'm going to make 2 new modules. I've got some more of this Vruzend stuff, and I don't know, put them on the back here or something, and just make this a bit bigger, a bit higher capacity. So what are these? These are Wix 10.8 volts. That's interesting. 10.8, 1.3 amp hours. So that's the 1300 milliamp hours. Yeah, that 10.8. I thought 3 lots. These are in a triangle formation. You can see where the 3 cells are. I thought 3.7s was 11.1. So they must be calling these 3.6 volt cells, which is interesting. Okay, according to the datasheet, they are nominal 3.6 volt cells, not 3.7, but there we go. Okay, so let's open up a few of these, get some cells out, and find some of my Vruzend system, and make up some new modules. Right, I've taken the screws out, take the top off. Okay, so there's the PCB. We can see current sense resistors there. Couple of MOSFETs. They're probably in parallel, and they will be the low voltage cutoff MOSFETs. So when these cells get down to I don't know, about 3 volts, then the power tool cuts off. Right, okay, so what have we got in here? Well, there's a temperature sensor there, a thermal cutout switch. What does that say on it? Well, I think, if I can get the magnifying glass right, I think that says 60 degrees. Is that what you're seeing? So I guess this battery pack would cut out at 60 degrees C. Right, these just lift out. So I guess what I'm going to do now is just cut off all all extraneous stuff, and then I've got to try and rip these little welded strips off the cells themselves. So let's get cutting. Just cut off all these unnecessary wires, which I'm not going to use. Can I cut across that one? Yeah, I think I can, because I'm not, that would be shorted anyway, wouldn't it? Okay, let's cut this black wire off, cut this white wire off. What else we got? That white wire, and red there. So that's got the circuit board off the unit. I'm not going to reuse any of the electronics, I just literally want the cells. So now it's a case of trying to remove these welded strips without doing too much damage to the end caps of the cells. So let's start by trying to roll these off. I don't want to pull on the base plates of the cells too much. That came off. Might be slightly more tricky. That's stuck around there now. Come off. It might be slightly more tricky doing that on the positive end, because is there any danger of shorting pos to neg around this cap area? Probably not. Okay, let's try a positive end. Can I roll the two halves separately? Yeah, I might be able to actually. That didn't quite roll, did it? Okay, that's got it off. Now there are some little pips on there. Let's take a closer look. Yeah, there are the weld pips. So how proud are they sticking up? A little bit. Now, they're not going to make the best contact with the Vruzend end caps, but then I guess this thing isn't really going to be pulling massive currents, so maybe I don't need to worry too much about these little pips on this end. And actually, you can see by the shadowing there, or the different lighting, I may have slightly distorted the base of this cell. There's a pip there that I'll need to cut off. So I'll just have a go at sort of trimming these. Let's refocus that. Trimming these with my cutters, and then I'll get them inside some Vruzend end caps. Right, I've got these three cells done. I mean, they're not super clean in terms of detritus from the welds left on there, but I think that's adequate. As I say, the more of these I put in this power bank, of course, the less current will be pulled out of each one. So I guess the end cap can just sit on those little raised weld bits. Okay, let's get, I want 8 of these cells in total. I've got 9 from my 3 batteries. Let's get some more of these cells out. Right, I've got 9 cells, so I just need 8 of them, leaving 1 spare. I'm sure I've got some more of these cells somewhere. I can't find them at the moment, but this will be enough just to add 2 modules to my homemade power bank. So let's get some Vruzend end caps. So here's my box of Vruzend stuff. It's actually Vruzend, made in India. There's some stuff on here. Where is it? Yeah, so Vruzend.com or Vruzend.in. So that's who makes this stuff. And then inside we've got the end caps, nuts, and also the long bolts that hold groups of 4 of these together. I'll show how that's done in a minute. And the little connecting strips. So let's get a module made up. So actually, let's take a look at a module. I'll take this voltmeter off. Let's look at a module by actually sliding one off this thing. Now I've made it even more modular by putting these linking pieces between what I'm calling modules, which is a set of 4 cells, offset slightly. So I don't know whether you can see that, but there's a nut in between the 4 strips that join the 4 cells in the module together and my linking strips. So I'll just get the, oh, I think it's 5.5 millimeter nut spinner for that. Yeah, 5.5 millimeter. So that's the outside, I think it's the across flats measurement of the nuts. I think they're 3 millimeter threads. So if I undo that linking strip, and also now, because this is an entirely paralleled block, I've not got any series elements in here, so it's just 3.6 volt nominal, 20 cells all in parallel. I don't need to worry if I drop this, because all these are positives and all the negatives are on the other side, so it's much easier than making up a series parallel pack, because you don't need to worry about, you know, if you've got reds and blacks on one side and you drop this across them, then conceivably there could be a nasty incident. Right, let me just get these two strips. That will liberate one of my modules, and I'll show you one module on its own. Right, if I take this strip off, I can now oh, I've got to do it on the other side, of course. I'll just do the blue side. Okay, just get those nuts out of there. And now this, oh, there's another nut. Oh, there are two nuts there. Okay, so this module now is loose. Now, which way does it slide out? That way. And out it comes. There we are. So what I'm calling a module is, like I say, a group of 4 of these cells strapped with 4 straps, held together with these long bolts that run through the middle. I think you can just see that. Can I get some light in there? Yeah, you can see the bolt running through the middle with a large diameter screw at each end. That just holds the caps hard on there, so that you get a good connection inside these caps. Okay, let's take a look at a cap. These caps have a spring, a leaf spring metal piece there, which you can push in because it's sprung, and it's got a welded 3mm stud on the inside. Does that? Sometimes you can push these out. You see, this one I can just slide out because it's not trapped on either dovetail. This one I can't, because it's trapped that way and it's trapped that way. So let's slide one of these out. You'll see the relevance of these dovetails in a moment. Yeah, so all it is a plastic cap with these recesses here and these dovetail shaped extensions there, a threaded screw and a spring. It's a bent over sprung connector in there. Now, when you assemble these things, it becomes very quickly apparent that you have to have recesses opposite dovetails, because when you make another module, because of the way these recesses have a fixed end, there's actually a little wall in there. These recessed pieces can only slide over dovetails from one side, and then they will hit that end stop. So you have to make sure that on the other end, you can't have recesses opposite recesses or dovetails opposite dovetails. And in the end, you end up with 2 sides which are all dovetails. These 2 sides are all dovetails. These are recesses and these are recesses. And at the other end, it's the exact opposite. Recesses opposite dovetails, recesses opposite dovetails, and vice versa. And that makes up one of these modules, and that also means that you can slide a module into an L-shaped corner like this. That can be slid in there. If you get these dovetails and recesses all wrong, you end up not being able to slide, well, that would be that way around, not being able to slide in new units. So let's make a new module. I will need 4 reds and 4 blues, like so. Let's get all my dovetails and recesses all in the right order and get some cells in there. So I've got dovetails on those 2 sides, so I can't slide that in there, even though it will go in there. That means I've got dovetails and recesses. That's not going to work. I need to have dovetails and dovetails, and now the other 2 sides of my module are all recesses. Will this slide in like that. Yes, it will. So that's an end cap. Let's get 4 cells in there, positives into these ends, like so. Negatives are all on this end, and now I need to build another square arrangement of this, which should be like that. Is that correct? Yeah, all dovetails along there and down there, recesses, recesses, and then it's just a case of finding the position where this is opposite. So we've got all dovetails over that top. Let's get all dovetails on this one down the bottom. So I think it's going to go on like that. Dovetails, recesses, recesses, dovetails, recesses, dovetails, dovetails, recesses. That looks good. Let's put a bolt through the middle of that. So the bolt is actually these kind of, I don't know, 1/2 inch bolts, 12 millimeters, and a threaded rod, and then that runs through the center of this thing. Let's get this all in alignment, and then I can put the screw in the other end and start tightening it up. And I had to make a special tool for this because it's very difficult. I'll show you actually. A stubby short length screwdriver works well for this, but as soon as you get enough torque on this or some tension on it, all that happens is that the screw at the other end starts rotating, and you can't really hold 2 screwdrivers and this at the same time. You'd need 3 hands. So I came up with a little jig, and it's this. It was an old hacksaw blade. Actually, it was a pad saw blade, I think, which broke off at the end, so I was going to chuck it. But I cut a little section out of the steel there. These teeth, they're not a major problem. It's a bit blunt anyway. So you sit that over there, and that allowed me to hold that screw stationary relative to the plastic. And if I just hold that in my hand like that, I can now tighten the other end of this and get this thing to fully tighten down. And while I'm tightening this, these end caps are pulling in because this screw sits on some little plastic shoulders there. And so I can tighten that fully, get a really good amount of pressure on the end caps. Now you can't go absolutely crazy with this, but what I want to do now is just check that the lengths are about the same. No, I could go a bit further actually, because those line up, but these are sat a little bit out. So I'll just tighten this a little bit more and get these caps pushed in a little bit harder. So just tighten that down a few more turns. Let's try that. Just line them up and see if they're the same. They're pretty close, so that's probably okay. Maybe another 1 turn. Right, now I'm going to put 4 of these strips on here. Doesn't really matter what sequence, but I might as well copy that. Okay, and we're all positive on this end, so we don't need to worry about connecting the wrong thing to the wrong thing. I'm actually just checking because there's a little burr on there, and I'm just putting that on the underside. Just being pedantic really. Okay, let's get the bolts on there, because as I say, the link strips that link these together, I'm sitting on top of the first nut. So yeah, let's get some nuts on here. And I quite like using this because what you can do is you can tighten it finger tight on the widest part of this, and that's just about the right torque setting. Any more torque and then you're in danger of, I don't know, pulling the welded stud off the metal inside. So I just do it finger tight using this 5.5mm nut spinner. So let's do that as tight as I can, just with fingers, no additional tools. That gives it a nice torque. Flip it over, do the blue side. Okay, do this up again. Finger tight, but tight finger tight, if you know what I mean. It's much pressure as I can put on. with my finger. Okay, so now we have one more of what I'm calling my modules, and hopefully these will slide into the existing power bank without any sort of dovetail and recess issues. Let's give it a try. It's turned into quite a nice day today, but the sun is causing havoc with my photography, so let's just pull the blinds down. Right, let's give this a try. Okay, so this corner is all recesses, so we want to get this corner all dovetails. Now recesses are capped off at this end, so this is going to have to slide in from this end. Similarly, this is all recesses and this is all dovetails, so that should slide into that corner if I can get everything to align. And there it goes. That slides in like that. Okay, let's do the next one, which will slide in on the bottom. Now, there is something else I'm doing. I noticed that if I had all dovetails on, say, the blue side, and all recesses, and then all dovetails on this side, this thing sat on the bench slightly lopsided, and that was annoying me. So I thought, why not alternate? And you can, with this modular approach, have dovetail recesses, dovetails, recesses, and here the dovetails, the sticky outy bits are there, recesses, dovetails. So in a sense, this has 3 points of contact. So it sits absolutely level on the bench, like a tripod, because we've got 3 points of contact. Where are the dovetails? There, there, and there. When I add this next row, I'll have 4 points of contact, but that's all right. That's also stable. So let's try. Now I can't put a module in there because I've got my little PCB, my power bank PCB there, so I can't slide one in there. So I'm going to slide another one. Can I put that down? No, not really. I can probably do it like that. Yeah, so let's slide another one on the back of here. So my modules are dovetails, recesses, dovetails, so I need recesses. However, I need dovetails on this side to slide into the recesses here. That means I can only approach it from this end. So let's slide that on like that. Got everything to line up. Yeah, that slides on like that. So that's it's extended my power bank to another block of 4, which I'm calling a module. And then to link these up, I'm simply placing these link pieces, well, wherever they fit really. So I can fit one there. I think I had one going vertically there. Remember, this is all red side, so I don't need to worry about getting these in the wrong position. I'm going to build another module and place it on top here, and then put more of these module links in. And as I said, I've just stood them off so that you can tell which are the module linking links and which are the links which link up the 4 cells within a module. Now I just spotted a problem actually. My next module has to slide in that way in these recesses to hit that end stop, but it would also have to slide in that way in these recesses to hit that end stop. Well, it can't do both at the same time. So that's not going to work. So do I take that out and perhaps put it up here? Do I start at the top? Does it mean that the sequencing has to be a certain way? Well, that slides in there. Now I've got all recesses down here and all dovetails there. So yeah, the next block can slide in from there. But yeah, it does mean that you have to sequence these correctly. It's very complex, this dovetail and slot idea. If they hadn't put these end walls in, if that had been open, you could have slid these in from either end. It would have made this a lot easier. Gosh, yes, I've got a lot more of these things, haven't I? I seem to remember I had Vruzend end caps for about 50 cells, and I think I've got about 50 cells because I had a lot of those Wix 3-cell power tool batteries. So I don't know where they are. They must have been in a box somewhere. But yeah, I got lots of these. So let's get some more of these out. Actually, I only need 2, don't I? Yeah, those 2. So that will make me another of my modules. Right, so here's my next module. I think I've got on with dovetails and recesses correct. Yeah, so let's slide this bolt through. Put the bolt in the top there, and then once again tighten the pack down using my modified saw blade. Okay, let's put these strips on. Now if you're thinking, Julian, you haven't tested the cell voltages. I wanted to do this consistently, didn't I? To make sure they're all the same when you link cells together. Well, let's have a think about it. Let's imagine these are at 3.6 volts. I'll check them in a minute actually to see. And as you saw earlier with my little voltmeter, I charged the main pack up to 4 volts. So we've got a difference of 0.4 volts. Now, is it really going to cause massive current flows if we connect cells at 3.6 volts to cells at 4 volts? The cells at 4 volts will pull down a bit. Now, there are a lot of them, so they won't pull down much. The cells at 3.6 volts will be forced to pull up a little bit. I just can't see it being a major problem. I don't think it's anything to get too het up about. So I'm not going to worry too much. I will check the voltage of these once I've got all these screws on. So let's just check these pack voltages, or module voltages as I'm calling them. Slippery black crock clip covers. Perennial problem. Okay, that is, I think it was 3.6, wasn't it? Okay, 3.6. The other one is almost certainly going to be 3.6 because these are fresh cells out of brand new packs which I've never used. The packs are very old, they're probably 2 years old, but I've never actually used them, so they're factory charged as it were. Oh yeah, these are a real pain when these things slip round. Oh, they're much higher. They're 4 volts. How interesting. So really the issue has already arisen because we've had 3 cells from one pack. Maybe I did charge. No, I can't have charged these packs because I don't have any chargers on them. So we've already had the issue because we've had 3 cells from one pack, or possibly 2 and 2. Who knows what the mix is, and I've already linked them together. So yeah, I just don't think it's an issue. I don't think, I mean, the initial current might be, I don't know, an amp or a couple of amps, but it will very quickly settle down as the charge redistributes itself amongst the cells. Just can't see it being an issue. So let's get these packs on here. Now I worked out, didn't I, that the first one I have to put on from the top. So let's do that. And now this module, I've got all recesses there and all dovetails there. So that should slide, get all my recesses. Yeah, that should, now that's going to have to slide that way. So the dovetails go into the recesses. And there it is, my now extended pack. So how many cells have I now got? It was, well, it's 7 lots of 4. 4 sevens are, what are 4 sevens? Yeah, 28. So 28 times 1.3. What's that? Yes, it's a 36.4 amp hour pack. So it's 36,400 milliamp hours now, this power bank. Right, let's get some linking pieces on. So to link modules together, I think I'm going to go up there. I'm going to come across there. Yeah, now sometimes the way these studs are positioned, you find that these strips won't bridge the gap. Oh, it will just about. Okay, so let's go, well, we can go across there and across there, and therefore I can go up there and up. Just want to get these burrs all downwards because I'm just pedantic about consistency. And perhaps another link there. Yeah, that looks good. I'll get nuts on all of that lot. These cells actually are optimized for high current, for power tools. Oh, this keeps happening. You put the nut on and it just flies off when you try to spin it. It's a real faff because the ends of these studs aren't beautifully produced. They're a bit burred. So I just can't get that nut to sit on there while I tighten it. No, they keep falling off. So like I say, these are optimized for high current. I think these cells are rated for 15 amps. So when I connect all these strips linking these modules, even if I get 15 amps just for a second or two, it doesn't really matter. The energy is going to redistribute itself very, very quickly, and the currents will all fall down. So there's no way you're going to see any, I don't know, heat in these strips or anything like that. Sometimes it's just a case of finding different nuts seem to sort of mate with different studs, and there's just no logic to it, so you just keep trying. There's one that's gone on, and it's a bit of a time-consuming thing, but eventually you find nuts that fit on every single stud. Okay, I think that's it, so I just got to tighten those down, and then come out. And then I will flip it over and start putting strips on the other side. Right, let's put link strips on the blue side. Once again, the stud spacings are quite variable, so I'm going to have to use the nuts to push those down. Okay, across there, down there. Oh, that felt a bit warm, actually. Am I dreaming it? Yeah, I'm dreaming it. That's not warm at all. Okay. Down there. Across there. So that's all the modules. Oh, I could link one at the end there. So that's all the modules linked together. Let's get the nuts on. Actually, if we're really concerned about this, let's just fire up the thermal imaging camera. But I've got a feeling by the time this boots up, any heat will have dissipated anyway. So I don't think we'll see anything. Of course, these are also shiny metal, so it might be quite difficult to get a heat measurement off them. Ooh, gosh, what's all that? Actually... oh, something's a little bit warm. Yeah, it's very hard to tell, but there does seem to be some warmth in there. So yeah, maybe some current flowed and it's redistributing itself across the cells, but I just don't think there's anything really to get alarmed about. What's the maximum temperature? 34 degrees. Yeah, it's not much, is it? And so that's it. That's my 36 amp hour, 36.4 amp hour power bank. All the cells in parallel, all 28 of them now. I can feel a little bit of warmth as the currents or the charge levels have redistributed themselves amongst all the cells. Let's see what this is saying. So it's saying 4 LEDs lit. I'll put the voltmeter back on now. And yeah, that's interesting because it was 4 volts on this front lot. One of these rear ones was 4 and one was 3.6. Interesting, isn't it? Anyway, it's now all settled down at 3.9 volts. I'll just put the thermal imaging camera on it again and just see if there's any warmth there. What you absolutely do not want to do, of course, is put one of these cells the wrong way round. That would be pretty disastrous. It would kill that cell fairly quickly. Yeah, there is a little bit of warmth in there, but look at the maximum now. It's down to 29. So something got a little bit warm in the middle of the pack there from underneath. One of them's warm, but what's the temperature? It's only 31 degrees. So something in there got a little bit warm, but I don't think it's anything majorly to worry about. So that's with some of the cells at 4 volts and some at 3.6, and I don't think it's anything to get too alarmed about. Well, I'll just use this to charge my phone using this watt meter cable that I pulled apart the other day. So that goes in there. That goes in my phone. And yes, that's charging. So the green light comes on here. That means that it is power delivery, so it's raised the voltage. I don't know what to. I suppose we could have a look at that actually. Yeah, what you can see there is 15 or 14 watts. But let's just put this in line, see what the voltage is. And it is 9 volts. Okay, so it's raised the voltage to 9 volts, 1.6 amps. What's that in watts? Oh, 15. Yeah, this phone normally charges at 15 watts. So 13/14 watts it's pulling. So yeah, PD has gone up to 9 volts. That's it then. I think I'll call it there.
Press the like button, why don't you?
Press the like button, why don't you? That's it for this video. Cheerio.